So let's say we've got the log base 2 of 3x minus 8 equals 4. Yeah. Log base 2 of 3x minus 8 is going to equal up to 4. What we're going to utilize here is a little technique. Recall from last time we talked about that if I have 6 to the log base 6 of 45, what happens there? We talked about that last time. The 6 and the log base 6 cancel out. They're inverse functions. They're inverse operations. So if I have both of them together, they cancel out. 6 to the log base 6, those are opposites, so they cancel out, and that just leaves me 45. Well, I don't have that here, but what I'm going to do is introduce that into this equation that I've got here, and it's called exponentiating both sides, or introducing an exponential. So I'm going to exponentiate, big word, both sides. And I'm going to exponentiate both sides to base 2. And hopefully you can guess why I would pick base 2 here, because that's logarithm base, right? I've got logarithm base 2, so I'm going to exponentiate. Here's what I mean by that. Exponentiate both sides means I'm going to put both of these now as they are. I'm going to put both of those as the exponent of 2. In other words, I'm going to do 2 to the log base 2 of 3x minus 8 this side. Then I'm going to do the same thing over here. See that? 2 to the log base 2 here of that, and then 2 to the 4. So I did both sides. I did the same thing, didn't I? What happens? Well, that's what we're just talking about. Over here, what have I got? I've got 2 and the log base 2, or 2 to the log base 2, so don't those cancel out? We looked at that last time. Yes, they do. And so what's left over here? Well, what's left over here is just 3x minus 8. Now, on the right side, well, I have 2 to the 4th, which is, what's 2 to the 4th? 16. Okay? Yeah, and so that gets rid of my logarithm and leaves me an equation, hopefully, usually I can solve. How do I solve that? Just get x by itself. Add the 8, so I have 3x equals 24. Divide by 3, I've got x equals 8. Now, here's a word of caution. That looks like a pretty good answer. However, be sure to check those. And basically what you're looking at checking is, make sure, because I've got logarithms, make sure I don't have the logarithm of a negative or the logarithm of 0 if I plug that in for x. That's what I'm looking for. Be sure to check to make sure this doesn't give you the log of a negative or 0. Because we just can't do that. We're talking about real numbers, and those aren't going to be real numbers. So make sure it doesn't give you the log of a negative or 0. All right, so in other words, if I plug in 8 there, is that going to be okay? I'll have the log. That'll be 24 minus 8. That'll be log base 2 of 16. So that's going to be okay, isn't it? If I plug in 8, that'll give me the log base 2 of 16. And that is going to be the answer there. So yeah, this is okay. Sometimes it may not. Sometimes it may give you the log of a negative, and so you just want to check it out, but it checks out. Okay? All right, so let's look at number 2 here. Say I have the log base 9 of 7t, and that equals 3. So in this case, I would exponentiate both sides to base 9, right? Because that's my logarithm base. So I exponentiate both sides to 9 base. In other words, 9 to the log base 9 of 7t equals 9 to the third. Well, the 9 and the log base 9 cancel out, so that just leaves me 7t. 9 to the third is 729. Yeah, just divide by 7. So it's easy little... and if you plug in t to be that, you're okay. All right, so that's the basics of doing it. Now, a couple of matters to consider here. What if I have this one? What if I have 5 log of 2x plus 700 equals 15? 5 times the log of 2x plus 700 equals 15. Well, a couple of things on this one. First of all, I have an extra number over here, the 5, in front of the log. Those others didn't have a number in front, so guess what I have to do with that number in front? I need to get rid of it. I need the logarithm to be by itself. So how would I remedy that? Well, it's 5 times the log, so I would get rid of it by dividing, right? One way to do it anyway. Yeah, just divide off 5 on both sides, and that'll get rid of it on this here left side, and it'll give me 3 on the right side. And so now it's just a regular log equation like we had. Now, second point. I need to exponentiate to both sides, but there's not a base showing up there. However, if there's no base on a log, what is it? It's automatically, which, 10? Yeah, that's log base 10. Yeah, if there's no base on log, now if it's ln, it's different, but if there's no base on log, it's understood to be base 10. Okay, so I'm going to exponentiate to base 10. So I have 10 log 2x plus 700 equals 10 to the third. Yeah, and then 10 and that log cancel out. So I have just 2x plus 700 equals 1,000. Subtract 700. So that'll be 2x equals 300. Divide by 2, and we got x is 150. Is that going to be okay? Yeah, if I plug in, just a quick little check. If I plug in 150 there, just making sure you don't have the log of a negative, and certainly if 150 is x, that's not going to be a negative. It's going to be the log of 1,000, so we're okay. All right. So there you go. All right. Question or concern? What about this one here? 7 plus 2 ln of 5x equals 18. All right, well, got a similar problem as we had earlier. One problem earlier there. This logarithm has some other stuff with it. So I need to get rid of the other stuff with it, move it to the other side in essence, and get the logarithm by itself. I want the ln of 5x all by itself. So I need to move the 7 and the 2. How do I move the 7 and the 2? Well, to move the 7 would be our first step, wouldn't it? How would I move the 7? Subtract it. Okay, so I subtract 7, so I have 2 ln of 5x equals 11. And then to move the 2, we divide it by 2, so we have ln, 2's cancel. So we have ln of 5x equals, and you can leave 11 halves. That one is a nice decimal. So let's, sometimes easier just to write the decimal than the fraction. So let's change that over to 5.5. Okay? Now, same idea here too. There's no base showing on this, so to exponentiate I need to know what base. What is the base if it's an Ln? That's base e. Ln is always base e. So when I exponentiate here, I exponentiate with base e. So e to the 5x equals e to the 5.5. And then the e and the ln will cancel out. So I have just 5x on my left, and then e to the 5.5 on the right. Then just divide by 5. So x is e to the 5.5 divided by 5. And then, get your number there. Plug it in. E to the 5.5. Now that's 244.69. Then divide that by 5. I get 48, depending on how many, let's say 3 decimal places. 48.938 to 3 decimal places. They want more, less, whatever, but to 3 it's 48.938. Okay, and that's, if I plug that in, no problems, right? We haven't run into one yet that it didn't work, so I think that comes up in just a second. But yeah, if I plug in x to be 48, that's not going to give me the log of a negative or 0, so we're okay. All right? Question or concern? So far, so good. All right. Well, how about this one? This one has an extra little twist on it. Log base 5 of x plus 24 plus log base 5 of x equals 2. Well, that's another matter, isn't it? Because on this one I've got 2 logarithms instead of just 1 logarithm. Well, you do just need 1 logarithm. And so guess what I have to do? I need to combine these two, condense these 2 logarithms into 1. That's right. Now, how do I do that? Do I just add them? These 2 combined be log base 5 into 1. What do I do with the inside parts? That's property number 1 of logarithms. They combine, but not by adding these 2. It's multiply, yeah. So I have to take x plus 24 times x, combine them by combining the inside parts by multiplying. That's how they combine. They don't add inside like that. They multiply. So this will be log base 5 of, let's go ahead and multiply. That would be what? X times x is x squared. X times 24 is 24x. With me so far? Sound okay? So now we have the 1 logarithm, and we exponentiate. It's log base 5, so exponentiate base 5. So we have 5 log base 5 of x squared plus 24x equals 5 squared. 5 and log base 5 cancel, so I have x squared plus 24x equals 25. All right, so now also this leaves us with another different sort of thing, and that is an x squared equation. How do I solve those? You can use square root sometimes, but this one is factoring, isn't it? I need to make one side 0 and use factoring. So I'm going to move the 25 over, make that side 0. So subtract the 25, equal it to 0, then factor. And that one just so happens to factor. X and x, minus 25 with 24 in the middle. Probably one we don't use very often, but it's 25 and 1, isn't it? Positive 25 and minus 1 would get us that factoring, right? That would give me a middle term of 24x, right? So that gives me potentially x plus 25 equals 0 and x minus 1 equals 0. Well, that solved out would be x equals negative 25. Add 1, so we get x equals 1. However, there's a problem with one of those. Which one of those do we have a problem with? The negative 25 I have a problem with. Why is that? If I plug in negative 25 here or here, either one, I have a log of a negative. And log of a negative, it's not a real solution, so that's not anything we're interested in right now. So I have to throw that one out. Now, if x equals 1, that's okay, because that would be the log of 25, log base 5 of 1, that's okay. Those are all okay. So it looks like the answer here, come to find out, is positive 1. All right, anything question-wise on that? Okay? All right, what about this one? How about log base 4, 5x plus 3, minus log base 4 of x equals 3. Well, same story here. I've got two logarithms on the left. I need them to be one logarithm on the left, so I need to condense these. However, if I condense these to 1 log base 4, the logs originally are subtracted, so I don't multiply the insides. What do? That's divide, yeah. So I need to divide the insides here, so it'll be log base 5 of 4, 5x plus 3 divided by x. This one divided by that one. That equals 3. All right, so it's, okay. Here it's log base 4, so exponentiate to base 4. So 4 to the log base 4, 5x plus 3 over x equals 4 to the third. 4 and the log base 4 then nicely cancel out, and leaves me only 5x plus 3 over x. 64 on the right. All right, so leaves me this equation, which maybe we've talked about once or twice before. How do I do that one? Multiply both sides by x, yeah. To get us started then on solving this, basically I need to get rid of it being a fractional equation, and I would do that, multiply both sides by x. Take this side by x, so do the same thing on that side, multiply by x, and then why would I do that? The x's cancel out. So I just have 5x plus 3 here equals 64x on the right. Now just solve for x, right? Subtract 5x. 3 would equal, what was that, 59x. And then divide by 59. And so that would get me 3 over 59 is x, which seems like a strange answer, but is that going to be okay? I plug in 3 59ths here. Yeah, that's okay, because that's still going to be a positive number. 3 59ths, that's positive, so it's not a negative, it's not 0. It's okay. 3 59ths. Okay? One more of these types. What do we do if we have this? Log base 3, 2x plus 50 equals log base 3, x plus 1 plus 4. Now, just FYI for you here, I don't think there's any that you have to do homework, but if you come across it, this one I've got logarithms both sides. If I had log base 3, 2x plus 50 equals log base 3, x plus 1, if I didn't have that plus 4 on it, this is like the exponentials. If I just have log base 3 equals log base 3, and there's no extra stuff out here, those just cancel, and you have 2x plus 50 equals x plus 1. However, that's not what I have here, and that's an easy one. that's not what I have here because of the plus 4, you see. So this is a little more complicated a deal. No, if you have log, log, and then a number, some extra stuff there, here's what you have to do. I do, in this case, have to get the logs on the same side. So I'm going to move this log to the left. And the way I do it, just by subtracting. I'm going to subtract both sides, log base 3 of x plus 1. And I'll have log base 3 of 2x plus 50 minus log base 3 x plus 1 equals just 4, because those wipe out now. See that? Because now I can combine these into one logarithm. It'd be log base 3. This one's like just the very last one we talked about. I've got two logs that are subtracted, so they combine into one log by dividing, right? The two insides. So it'll be 2x plus 50 divided by x plus 1 equals 4. With me on that? Now I can exponentiate both sides, base 3. So I have 3, the log base 3 of 2x plus 50 over x plus 1, equals 3 to the 4th. 3 and the log base 3 cancels, so I have 2x plus 50 over x plus 1 equals 3 to the 4th, 81. So again, this one is just like previous one, because now we've got a fractional equation. Multiply both sides by x plus 1. Cancels out the x plus 1 then. On the right, left, and then so we have 2x plus 50 equals, and this, you do have to multiply the 81 by both, so it'll be 81x plus 81. Now it's just get the x's on one side, constants on the other. So let's subtract 81x. Go the other way if you want, and I'm going to subtract 50. Mine anyway, so that'll be this side, negative 79x. Those will go out. This side, the 81x's go out, so it's 81 minus 50 is 31, I do believe. Divided by negative 79. So x is negative 31 over 79. Uh-oh. Is that going to be okay? Yeah, I think it's okay. It's negative, but it's okay, I think, because if I plug in negative 31 over 79, which that's not even a half, if I plug that in here, 2 times that plus 50, let's check. Negative 31 over 79